Today we're doing the first day in section 11.2 and we're going to talk about finding limits again algebraically, not necessarily looking at a graph. So here is just some kind of general properties. Overall, they all kind of boil down to the idea of whatever the value is approaching, you plug it into the limit, and whatever answer you get is what the limit is approaching on either side. So notice the first one is kind of discussing if it's a constant versus a linear. So if it's linear, quadratic, cubic, so essentially if it's a polynomial, your limit's always going to be the same as, notice, as f of a. So then we have sums, differences, products, powers, quotes, and quotients. And again, the idea is kind of the same. You plug in that value and whatever you get is what the limit is approaching. So it's a pretty basic lesson for today. So here we have the problem, the limit as x approaches -4 of this linear line x plus 9. So over the next couple of days we have to start reviewing what linear, cubic, and all these different functions look like. So I know a linear piece is a straight line. So if I plug in -4, -4 plus 9, and essentially the thought process behind this is the limit as x goes to -4 of x plus the limit as x goes to -4 of 9. And because this one's constant, the answer is always going to be 9. The y value has to be 9. Here, if x is going to -4 of x, it has to be -4, so -4 plus 9 is 5. So the limit as I go towards -4 has to be 5. So here is a quadratic equation because it's squared, so this shape will look like a U. It's called a parabola. So again, we just have to plug in our 5. So the limit as x goes to 5 essentially is the thought process of the limit as it goes to 6 times the limit of it going towards x squared. So here when I plug in 5, I get 25. Here the y value is always going to be constant of 6, and then when I multiply these two together, I get 150. So the limit as x approaches 5 is 150, which means the y value is going to be 150. So here, the limit as x approaches -2 of the square root of 4x squared plus 5. So again, we essentially just plug in -2. So I keep the square root. I have 4 times this -2 squared plus 5. So I have 4 times 4. So now I have the square root of 16 plus 5, which is the square root of 21. And I know 21 cannot break down, so the y value would be the square root of 21. Now obviously if we were using this in a calculator, you would type that and you would get the y value as an exact decimal if we were looking at a table or whatnot, or if we were looking at it graphically. It would be a little under 5 because we know the square root of 25 is 5. And then the last one we're going to discuss is quotient. So notice I have this third degree polynomial, so it's a cubic polynomial over a linear piece. So as long as when I plug in 2, as long as the denominator, so as long as this part does not equal 0, I can just simply plug it in. In tomorrow's lesson, we're going to discuss what happens when it is 0. So in the numerator, I have 2 cubed minus 3 times 2 squared plus 7 all over 2 times 2 minus 5. So in the top, 2 cubed is 8. 2 squared is 4 times 3 is 12. In the bottom, 4 minus 5 is -1. So in the top, if I add 8 minus 12, I get -4 plus 7. -4 plus 7 is 3. But again, I have to divide this all by -1. So this limit is approaching the y value of -3. So essentially these basic ones, you just have to plug in the value and whatever you get is the limit. Now obviously in tomorrow's lesson it will get significantly more difficult. Again, these are just basic ones.